This texture gets generated on demand with all settings in RAM. Hello and welcome! Today I'm going to show you how the character customization generator in A World of Little Legends is working. If we create a new game, we are brought to the character creator and we have a lot of options to customize the character. At the moment we can see a preview of the animation already going on with the blinking, and we can rotate the character. In addition to that, we can live update some settings of the character, for example like the gender, or we can switch between humans, elves and capawns, which is the cat boy and cat girl race in the game. We have a set of different hairstyles to choose from that can be combined with the different other settings. And the last thing is the beard selection. We have a variety of beards, and all of these can be changed as one likes, but also be colored. So, for example, we can change the skin color to a very, very pale one to create a vampire-ish look. That's a funny beard. We are going for no beard, and then for the vampire look we add the black hair, and then we have the style. We could also change the eye color here and then watch how our new created character looks from all sides. Below the color picker there is a selection to go to vibrant colors, to have these very, very highly saturated colors. But we can also switch to a more pale palette, and as you can see, all the colors that are applied with different brightness. So we have a grayscale image that is being used to colorize all the different assets of the character, and the grayscale palette or grayscale image is being colorized by the color we chose. But this causes problems as soon as you go to the very darkish or very brightish colors. They get more and more desaturated. And I'm going to show you how I solved this problem with the desaturation that you can see in other games happening when doing a grayscale-based colorization of customizable characters. Beside the body and hair and beard settings in-game, you can also craft some clothing like a leather armor, which changes the body of the character. In order to create an animation, I first draw the animation here in Sprite. And in earlier days, it's actually true, I made all the animations in MS Paint XP. And here I look for how the animation looks like in general. I have a combination of 3 directions, and these are the parts of the animation. Every animation consists of 3 body parts, one for the down direction, for the up direction, and for the sideways direction. And these bodies are then combined with different arms and shoes, and from them it derives which positions the heads will have in each animation frame. So we have a setup that defines also the arm position, the head position, but only requires a single frame of body for each direction. After that, everything that is colorable by the player gets desaturated, like the arm parts here, and by that can be recolored by the system. The recolorized elements are the arms, of course, and the head, so everything that is skin, but also the eyes and the hairstyle. These elements are specifically drawn and then put into a folder of the character creator, to be used by the system. As you can see here, we have a lot of different images. These are all the different arms for the animations to be used. Every single animation uses their own arms, like a slash animation, a pickup animation, the walk animation, digging down, whatever. So we have all these here. We see the bodies as well. These are the different clothings in the variations for female and male and the 3 different directions. But we also have the ears, for example, then we have the eyes, and what can be seen a little bit better here is the hairstyles. Some of the hairstyles also use a second layer. After that, we have the different hats that can be recolored, and as the last thing, the shoes that are combined with the bodies. So all of these together are combined by a configuration, and they result into animation sheets of the different layers. And these layers, for the different animations, we have, for example, walk, stand, pick up. We take a look at this. And then we see the different positions of the arms when reaching down. After that, we have the beards. We also can see the different bodies here. And inside of this animation frame, we can see how things have been combined by this animation creator, like making this step to reach down for something. Or we can take a look at one of the hairstyles here. And when we open up this image, we can see that the position of the hair is being adjusted by the animation creator to show how the character is moving up and down, or for the sideway animation, it's a horizontal offset. So you can see how the character is reaching down. But all of these different layers are yet separated to be recombined later in Unity. So far, you can see everything in gray that is colorable by the player. In comparison to that, the bodies are actually colored. They are not recolorable by the player, and by that are drawn as they are.
Sein. Die Dinge, genauso wie auch die Augen und die Ohren, sind in Graustufen gehalten, während die Bodies fertig gemalte Sprite Sheets sind und dementsprechend auch so Einzelgrafiken und so zu Sprite Sheets zusammengefügt wurden.
Here we see the setup of the animation creator. We have one animation configuration file for each animation, like the slash animation to attack. And inside of the animation, we have one setup for each layer that is inside of the animation. For example, we have the top layer for the hair, and inside of that we can reference the graphics that we want to use for each frame and the corresponding offsets in X and Y position. So we have a single configuration per frame and per direction. So we have the upwards and sidewards here. The first one was the down direction, which then fully defines this animation sheet. And here we see the head, for example. Some of these images also contain placeholders that different types of variations can be inserted. For example, with the armor, we have different armors for the body with different genders, and each one of each combination can then be generated by the system into an animation sheet with leather armor, a tunic, whatever, for the character animation. Now we are inside the Sprite Builder, which is the core of the whole customization system. Before that, we have been outside of Unity. This is now inside of Unity. Everything we've seen before was creating the images, for example, in Sprite, and then recombining those with a node script with a configuration for each animation. And now we are taking all of the different animation sheets of the different layers and are recombining them inside of Unity. A lot of tutorials suggest that you just take the different animation layers and then you recolor them, maybe by adjusting the sprite color or using a shader, as different layers on top of each other inside of Unity. And this can lead to the problem of desaturation for brighter or darker colors, but also you have to synchronize all these different layers. As you can see, we already have quite some layers and there might be even more in the future. This can become quite cumbersome, and also you have a lot of pixels that are drawn on top of each other, and it is a lot of layers, a lot of game objects that have to be synchronized while playing the animation. So the solution that I am doing here is to load all the textures in advance, repaint them and recombine them into a single texture to be directly used out of RAM. Thus, we also only generate the one sprite sheet that we currently need. So for example, for the body we have a type, which can be a leather armor, for example, and we also have a secondary option, which can be the gender. So we can load in a leather armor for females, for example. There we see the image, and this is then being used for this layer. For the head, we don't have any variation, but there are also a few other layers which have variations. We have a beard type, we have a hairstyle, different ears, and also different eyes. And we take all of the animation sheets, we load them and repaint them if necessary. So we make this based on the texture size and then paint one layer onto another inside of this new texture 2D that we created. To combine all these different layers, I use the draw method that I created, and I pass into that my target texture and the new layer that I want to add to that texture. I also pass a color if this is a layer that can be recolored by the player. And then I'm going to get the pixels of both textures, which is very easy with a get pixels function. So I get the pixels of the target texture and then the pixels of the new texture that I want to draw on top of the current existing target texture. And after that I have to check for the alpha value, because I only want to paint non-fully transparent pixels. Otherwise I would just delete my current setup with every new layer I draw onto it. And then I repaint every single pixel in the texture. We have the current texture pixel color and then the new pixel color, and also the paint that we want to apply to this pixel. If we don't want to apply any paint, we just return the new color, and otherwise we look for completely visible pixels and then we will recolor these pixels and apply them. Otherwise we apply some alpha blending to that very pixel. Let's take a look at the relative color function. This is the core element for recoloring the pixels. First, we take a grayscale pixel color. This defines the brightness that we want to have for our target paint. But, as said before, the further we go to very bright or very dark colors, we are losing saturation of the paint. So what we have to do is, in reverse of the brightness change, adjust the saturation. And this is done by this little formula here. So we are measuring the difference of the value of the color, and then in reverse we apply this change to the saturation. So for example, if we have a color with a very low blue and green value, we have a high red value, and then we lower the brightness. All the three values get lower and lower, but we are getting ever lower with the previously high red value, so we are losing saturation. By applying this to the colors, we can shift them a little bit apart of each other again. So we can increase the saturation by manipulating the single color values, and thus not getting more and more gray as further as we go to the extremes. Thus, instead of getting more and more grayish, we maintain this kind of saturation, which is a very, very nice thing to have. After that, we have the alpha blending function, which is very simple. We just take the color and apply the alpha value that we want to have and blend it with the color that already exists in the texture. After that, we have to do a few little things to make the texture work. So we applied all the different layers, and then we have to set a few flags because we are in a two-dimensional game, so we want to have the point filter, and we also want to use the clamp mode for texture wrapping. And one of the maybe most important things is, after all of that, we need to apply. We have to call the apply method. Otherwise, we will not see any changes in the texture. But now that we applied our changes, our pixels to the texture, we have a very new virtual texture, which is pretty much the same as when we would load a texture from the asset database. And we can now apply this texture to a sprite, for example, just as it would have been when creating a sprite in Unity, which has a texture. And then we can use it for our animation sheet. We can slice it if we want to. And since we have our animation directions in the proper order based on our source files, we have the up, down and sideways directions inside of our animation sheet, and everything is ordered in the animation layer order that we applied the textures on to use it.
Textur ordnen wir dann einem Sprite zu. Dort kann man dann auch noch, wenn man möchte, dynamisch die Textur slicen oder die Offsets berechnen, wie viel tatsächlich von einem Ausschnitt gezeigt werden soll.
After creating the texture, we now have to slice our texture into different sprites for our animation paths. This is done in the build paths and build path methods here. So in order to find out how many slices, how many steps we want to create, we can derive this from the width of the texture in combination with the size of each frame. And then we simply create a new sprite for each of the slices. While iterating through the texture, we also pass a new pivot point, 0.5, like the center, and we pass in the pixels per unit that we want to have in the game, and then apply all of the resulting sliced sprites into this list. So we have a list of sprites that we can iterate through and apply them to the sprite renderer. Here we finally see the result of the whole system. For example, the walk animation. We also have a different piece of cloth applied to our character. We can use a pickup animation or, for example, a tag animation, as you see here. Everything is based on the recombination and recoloring of the different animation layers. and they are put into brand new virtual textures. They are not placed onto the hard drive or loaded from the hard drive ever. So they are purely inside of the RAM of the game. And when we change anything about the setup of the character, this whole process starts anew and a new virtual texture is created. The last one is removed from RAM. We can see this, for example, when removing the piece of cloth. Now we have a different piece of cloth applied to our character. And as said before, the previous texture is just being removed from the RAM. This is how the multi-layer recoloring character customization system in A World of Little Legends is working. And I hope this helps some of you if you want to create a more complex character customization system for your own two-dimensional games. Also, feel free to pick any parts of the code you have seen in this tutorial. This is absolutely fine. Have some fun implementing your own system. Till then, bye bye.
Viel Erfolg. Danke fürs Zuschauen und bis zum nächsten Mal.